Okay, and we should be live. Is my audio all right? I think it is. It sounds good. Um, let's continue then. Okay, so last time we left off at uh, constant and strings, and we're going to now be doing the chapter 5 summary. So, and then we'll be moving on to operators. And we'll see where we get to on that. Why is my screen not showing anything? Hang on a sec. Um, Hang on a sec. Let me just. Okay, there we go. Cool. So it should now be all good. Apologies for that. Is it all good? Yeah, it looks all good. Okay, so where were we? Yeah. So we were, yeah, as I was saying, we were essentially, we'd finished consonant strings. We were now, moving, coming to this summary. Yeah, I think that's okay now. I just want to make sure everything is actually running properly. Um, should be all good. Yeah, everything's all good. Cool. Audio and now visual. Okay, cool. Let's continue then. Okay, chapter 5, summary and quiz. So, a constant is a value, yeah. A name constant. A literal constant is a constant value not associated with the identifier. So, for example, if we did standard character output, hello world, that would be a literal. And a literal, remember, can be used in a constant expression. Yeah, there we go. A variable cannot be changed. A variable whose value cannot be changed is called a constant variable. The const keyword is used to make a variable constant. Avoid using const when passing by value or returning a value. A type qualifier is a qualifier that is applied that modifies how a task is performed. Okay. A constant expression is an expression compiled at runtime. No, that can be evaluated at runtime. An expression is an expression that is considered a runtime expression. A compiled time expression is a constant. That's what we just read. A constant expression must be a compiled time constant. And then we learned earlier what that was in the last stream. Literals are values directly into the code. A magic number, which we don't really use. Decimal is 10 digits. Binary has 2. Octal has 8, and hexadecimal has 16. With with hexadecimal being 0 to 9, and then A, B, C, D, E, F, I believe. Yeah, with A, B, C, D, E, F. They are example of numeral systems. Numeral systems. A string is a collection, and remember we can use the library or header of include string to access that. A standard string lives in the string header, but it's expensive, remember, because string is the owner, whereas string view is the viewer, and it's less expensive. Because C style, yeah, and you can set, you can create a C style string and then set it, or then use it for a standard string view. Makes sense. Okay. Why are name constants often a better choice than literal? Using name constant in your program makes it harder. Symbolic constants document. Okay. Why are const and const expressions vary usually a better choice than defined? Defined constants do not show up in the debugger and are more likely to have naming conflicts. Okay, let's find the issue in the code. So we got include C std int standard int. We got a include input output stream. We got a standard character output. How old are you? We got a standard unit. So we got an integer with 8 bits, and we got age. And then we have output of age. Then we have a standard character output of allowed to drive car in Texas. If age is 16, standard character output. If age is greater than or equal to 16, yes, no, and then standard character output line n. So that's fine. You got an integer of you got a standard integer which it has a range. Oh, there we go. We've got an unsigned integer with a bit value of 8, and I believe bit value of 8 goes from 0. Unsigned integer goes from 0 to 127 or something, or 100 something. Then they enter the age. And then if age, I think the best way to do that, and then we can deconstruct it, is include C standard int, and then we'll include obviously input output stream. We'll have a return type of integer for our main, and we'll do standard character output. How old are you? With a I'm not sure how I feel about that line break, but we'll copy the code anyway. We'll do a standard unsigned integer of 8. There we go. Because is it a character? Because it's a character. Is that why? Because this returns as a character, possibly, not an actual integer. whereas this is an integer. So perhaps we get rid of this and just do int, but we'll find out in a minute. Standard character input, cin, character in, insertion, and then age. And then standard character output, allowed to drive a car in Texas. And then we obviously don't need a new line here because the new line will go on the same line. Yeah, so if age is greater than or equal to 16, and we say yes, else standard character output no. Standard character output, and then, well, that's one issue there because we've got a full stop here and then we've got a line break. This needs to be at least double quotes, so I'm going to change that to double quotes. And if anything, I think return 0. If anything, I think they should be here anyway. So let's run that code anyway and see what happens. I will just increase the size of my terminal, run the code. How old are you? And we'll do 6. See, there we go. So we've got the line break here, which is what we don't want. So standard character, because standard character input always produces a line break anyway, so we can actually get rid of that. I want more space there. So what we'll do is we'll hide that. We'll exit the program. We'll clear again. We'll run it. How old are you? 6. Are you allowed to drive a car in Texas? Yes. And so we got an issue there. So I think what if we did 16 there? For integer. So if we cleared, and then we ran, and then how old are you? 6. Are you allowed to drive a car in Texas? No. So the issue there was clearly, as I thought, potentially, yes. So I remember now. Unassigned integers when 8 return a character. As you can see here, we got a unassigned char, but unassigned int 16 and above, so 16, 32, 64, return an integer or a short. Yes, so that's why. And also, I don't like this, so I'm going to get rid of it. And then I'm going to do a full stop here, and then a line break, and then a full stop here, and then a line break. Because, so if we use standard character input unassigned, standard unassigned integer 8 t, this will return a what will it return? A character. Whereas if we use standard unassigned integer 16, this will return a short int, because we got unassigned short int, which is what we want. We want an integer, and a short is an integer, whereas 8 is a character. Yeah. So I'm a lot more happier with that. So let's go there. How old are you? 6. Allowed to drive in car in Texas? No. How about you are 19? You are 19, allowed to drive in car in Texas? Yes. So now that we've sorted that, our logic also works. Okay, let's have a look. On line 8, define an integer. Exactly, a char type. Using it here will mess it all up. A regular int should be user stored. We can also remove that. Yeah, I can see that. On line 13, yeah, cool. So one of the differences is with string view is that between string and string view is that we have string being a integer. Sorry, what am I talking about? String being a owner and string view being a viewer. And string is modifiable, but it's expensive to copy. String view can be dangerous when the string being viewed is destroyed before the string view is viewing it. That is true. Okay, let's give this a go then. So where was I? Get rid of this. Write a program that asks the age, name and age of 2 people, then prints out which person is older. Here is a simple output from the program. So enter name of person 1, enter age of that person, enter name of the person 2, and then enter age, and then whoever. So if name 1, if person 1 is older, then run that. Okay, let's give that a go. So I'll do include input output stream. We'll do include input output stream. The display is still good. Okay. Include input output stream. Go away. And then we'll do include string, and then we'll do include string view, and then we'll have a return type of integer main, and then we will do the standard return 0 as always. So I will probably put these into functions eventually, but for the time being I'm going to write each statement in this main and then probably convert it into a function. Okay, so standard character output, enter name of person 1, and then they'll enter, and then we'll need to do standard string of standard string person1, and that will be empty. And then we will set, we'll then do standard character input and allow the user to enter person1. Then what we'll do is let's set the string view. So std standard, so standard string view p1 is equal to person1, and then enter the name. So we've set the name, we've allowed the user to enter the name. Then we want a standard character output of enter the age of, and then let's do p1 because we want to copy from the string view and it's less expensive. p1, and then what we'll do is we will do that, and then we'll do std, we'll just do an int actually, int person1 age, and then we'll allow the user to enter person1's age, person1 age. Then we'll basically do the same, so standard character output, enter the name of person 2. Then we got a string of person 2. Then we want a standard character input of person 2. No. Then we want a standard string view of p2 to be equal to person 2. And then we will set standard, we'll do enter person 2 name, standard character output, enter the age of p2, and then we'll do that, and then we'll create an integer of person 2 age, unassigned for now, and then we'll allow the user to enter person age, person 2 age, and then we will do that. Then we'll do standard character output. No, we will do so I'll do hang on. So we would need if statement. So if, logic, if person 1 age is greater than person 2 age, then we will return we will do standard string view standard character output. And we will do person, no, person one, and then space, person one age, who is person one age is older than person two, who is, and then person two age. I think instead of person one, no, instead of person one, we should be doing P1 and P2 because it's a string view. So for now, and then else, we'll do that. And then we'll do P2, person 2 age, P1, person 1 age. So let's have a look. I might have to use static cast new type expression, possibly. Although thinking about it, we're not changing integers here. But if we want to get it in brackets, perhaps maybe we should. So let's just have a look at this, see where we are. So let's run that, and we'll do enter name of person one, John Bacon. So we've got that issue of that we had in a previous example where it goes straight to it. And that was because, now that I'm remembering, that was because we need to include get line, don't we? Yeah. So in here, so we need to use get standard get line and then standard character input. What was it? STD WS, and then it would be person one. I think that's the best way to do it. So we'll do standard get line, and then we'll do standard character input person one. Standard character input standard WS person one. I believe so. And then for this one, we'll need to do the same thing. So we'll do standard get line, and then we will do standard character input, and then we'll do standard white space, and we'll do person two. Let's see if that improves the code at all. Let's run it. Enter name, John Bacon. Enter the age of John Bacon, 37. Enter the name of person two, David Jenkins. Enter the age of David Jenkins. 44. So we should hopefully get David Jenkins is 44 and John Bacon is 37. Cool. And so what I actually want to do there now is add a line break. After a full stop. Yeah, I mean, we could put it into a function. But it's a fairly simple piece of code. Let me just make sure that the percentage symbol has gone. And let's now make John Bacon older. So John Bacon, this time he's going to be 44. David Jenkins, this time is going to be 37. So we should have John Bacon, who is 44, is older than David Jenkins. Let's press enter. John Bacon, yep, cool. Let's see if he put it, yeah, get name, get age. And then, okay, he did a much more. So let's actually put that into a function then. So we'll need a get name, function. We'll need a get age function, and we'll do a print result, which will be a void function. So we'll do int get name, and then we'll do void print result, and then we'll do sorry, that shouldn't be, that should be no, that should be string. Yeah, std string. Standard. That's the first time I've ever done that as a return type. So we'll do int age, and then we'll do here we'll do int person 1 age, and we'll do int person 2 age, and in here we'll do standard string view. Yeah, standard string view, and then SV, and then here we'll do person age. So then what we need to do is we need to we can move this here. We can get rid of the person, enter the name of the person, enter the name of the person, and then we are setting into the person's age. No, wrong one. Enter the person's age. Person age. Person age. And then person age. Here, enter the name of person SV, and then SV, and then equals SV. And we don't actually need that because we're setting the string view to SV, right? std standard, no inheritances. So, okay, so get age needs to have, oh, so it's the other way around. Okay. So get name should actually have a integer of num, and then standard age should have string view SV. Enter the that makes sense, because in order to enter in order to get this, we don't want enter the age of age. We want enter the age of the person who okay. So enter the name of person num, and then a line break, string name, yes, and then we want to return name, and then in here we want to return person age, yeah, age or person age. Then in the print result, we will want to we'll want this logic in print result. Don't worry about the errors. We'll just do if 0 to cancel everything out, and then end if for now, just to get that out of the way. So then in our print result, we will do we will call string view. Yeah, that's what I was thinking. So standard string view, name 1, int age 1. So standard string view, and then it's name 1, and then we want int age 1. Then we want standard string view name 2, and then int age 2. So then if age 1 is greater than age 2, print name 1 who is age 1 is older than name 2 who is age 2, and then name 2 who is age 2 who is older than name 1, and then age 1. So we can then get rid of the if and end if. So now what we need to do is, so we'll do if 0, and again we'll just comment that out with end if. Now what we need to do is call print result. But what we first need to do is because if we just called print result, we would need the string name view. So what if we just did, but the thing is it hasn't got anything to call against. So which is why we need to surely create the variables to be able to call it. So if we did in here, what if we did print result? I'm not sure if this would work. And then we did the string view name. So we did get name, but then we'd need to pass in still an integer. An integer. So if we did int age, and then if we did standard string view, standard string, and then we did name, and then we did print result, and then we did name age. I don't think this will work. Name age doesn't feel right. Okay, so we did const instead. Standard string name 1. So int age. So we did constants, ints. Okay. So I just missed out this bit as well. So we'll do const standard string, and then we'll do name 1, and then we're getting get name, and then we're setting that's why, because we're setting it to a literal, which means it can compile quicker, but std string is not, so I don't think that's the case. Then we do const int, and again I'm trying not to look at the answer, so it gets in my head better. We'll do age 1, and we will set that to get age. No, we will set that to age, and then we will set that to name 1. Yeah, name 1. And then we'll do the same for person 2. So const standard string name 2, and we get name, and we set that to a literal of 2, and then we do a const int age 2, and we're setting that to age with a parameter of name 2. Then in our print result, we can then do, what's the order? Name 1, age 1, name 2, age 2. And then that, and that's fine, we're getting an error because semicolon. So that hopefully should run. Let's see. Enter per, no. So what have I done wrong there? That's why, because our character input automatically produces the line break, so I don't even need that. So that was my bad on that. So let's clear this. Let's run it again. Enter name of person. There we go. So enter name of, so there, enter name of person, and we want a space, so we do a space there. So again, I'm going to stop this here and run it back again. Enter name of person 1, and we'll do John Bacon. Enter the age of John Bacon, he is going to be 37. Enter the name of person 2, David Jenkins, and David Jenkins is going to be 37. David Jenkins, so I've messed up there somewhere. They're both 37. Okay. So what we'll actually do is we'll add a bit more of logic. If else age 1 is equal to age 2, oh sorry, not if else, it should be else if. What am I talking about? Else if, it is that, right? Else if, yeah, else if age 1 is equal to age 2, there's a space there, my bad. And then we'll do the same age as. Cool. So we know it's working that, so now we can get rid of this and clean up our main function. We can clear this, we can do that. Enter the name, let's just do John for now. John is 37, David is also 37. John is the same age as David. Cool. So then if we do John is older, so he's 44, and David is 37. Cool. Nice. Why can't variable? It can't be a constant expression because the program doesn't know what the age is at compile time, right? No. A constant expression requires a constant expression initializer, and the get call isn't allowed in the constant expression because it's not a literal or a what was it? A literal or a literal or a constant objects whose initializers, i.e., what you're setting it to, are compile time constants. Okay. Next, we'll move on to operators. But first, what I want to do is I want to make a note of that. So this is all about standard string. Yeah, I want to make a note. I want to include this so I know in the future to come back to it. Okay, so operator. So what we'll do first is we'll do day 11, and this is part 1. And then, so what did we do? We did finished off the summary of what was it? What is it called exactly? Constants and string. Yeah, that's what we did. Tutto bene. And today's date is the 9th of August 2026. Cool. And then if we commit, yeah. So for now, now we're moving on to operators. And I'm going to take a quick break here, and I'll be back in a minute. Okay, and we're back. How how is the audio looking? Let me just double check. One. Okay, good. Right, let's continue. Where were we? We were yeah. So we were on operators now. So operator, precedence, and associativity. So yeah, let's continue. This chapter builds on the introduction to literals. So we'll start making notes. So up here in our notes, we'll do 10, and then we'll just do operators, and then all the way down here, we'll do this, and then there. Okay, cool. An operation is a mathematical process involving 0 or more input values, called operands. Yes, we've done that in previous lessons. So that produces a new value called a output value. The specific operation is to be performed with a symbol or pair of symbols. So for example, 2 plus 3 equals 5, and the plus sign is the operator. Okay, evaluation of compound expressions. Let's consider a compound expression such as 4 plus 2 times 3. It should be grouped as, which are values at 18. Yeah, so simple BODMAS. So BODMAS. So, which is brackets, order, multiply, what is it, addition, and then subtract. So you do 2 times 3, which is 6, plus 4, which gives you 10. In order to evaluate an expression, the compiler must do 2 things. So let me just copy that. And then at compile time, the compiler must pass the expression and determine how operands are grouped. This is done via the precedence and associative relativity rule. We'll discuss that in a moment. So let me just copy that. I'm copying it and not writing it out because I'm fairly comfortable with BODMAS and operands at the moment. And I'll only type it out to make myself learn if it gets really complicated. So, at compile or runtime, the operands are evaluated and operands execute to produce the result. Makes sense based on what we've done previously. Operand precedence. Operands with high precedent level. So basically this, I think what they're referring to is BODMAS. You can see the table below. What table below? No. My bad, it's not actually. Left to right. Okay. Multiplication and division have a higher precedence than addition and subtraction. So it is. So in BODMAS, division and then multiply, divide, multiply, that is annoying. Divide, multiply, and then add and subtract. That's what he's referring to. Thus, multiplication will be grouped with operands before subtraction. Makes sense. Operator associativity. Consider a compound expression like 7 minus 4 minus 1. Should it be grouped to evaluate 2? Yeah, so we don't actually need that because we're doing minus and minus the exact same. If two operands, yeah. Okay, so then precedent. So C. So what I'll just do is that there and that there. Yeah, cool. And then what I'll do is I'm not going to copy out the whole table, but C table of operator precedence and associativity in lesson 6.1. Okay, and then we'll have all of that left to right. You got the and or logic. Okay, parenthesization basically brackets. Use parentheses to make understand. Yeah, that's a decent best practice. The best practice is to use brackets to make compound expressions easier to understand. Cool. Yeah. A good rule of thumb is to parenthesize everything. Yeah, cool. For example, this is okay. Instead of this, do this. This is when using expressions with a single assignment operator. You do not need to have the right operand of the assignment, i.e. the one to the right, repped in brackets. Okay, makes sense. C++ standard uses the term value computation to mean the execution is an expression to produce a value. For example, 4 times 2 times 3, the value composition must happen first. Yeah, so again, BODMAS. So that the computation can be compiled. Yeah, cool. Evaluation of operands. Yeah, I don't. This is fairly basic stuff, so I'm skipping over it. Um, yeah, but it's possible to write programs where the evaluation does matter instead of this program that people often make mistakes with. So you got to get value, enter the integer of x, character input, and then return x. Print calculation, int x, int y, int z. We got that, and we're printing get value, get value, get value. Yeah, it's unambiguous. The best way to do that would be to make int a um, int a and then call get value, int b call get value, int c call get value, and therefore in my print calculation I can do a, b, and c. So let's just best way to learn is to practice. So include input output stream, and then you got int of main, and then we have a get value, and then we have a print set value. So we got a int get value, and then in the body we have a standard character output of enter an integer. Then we have an int of unassigned, and then we're allowing the user to try and enter something, and then we're returning said value. Then in our void print, because all we're doing is printing, we're not returning anything, print calculation. We want we'll do an integer of x, an integer of y, an integer of z. And then within that, we will be doing print calculation. We'll be doing standard character output, and then x plus y times z, making use of the parentheses, the parameters, sorry. So that should go there. And then obviously a semicolon. So then what we need is we'll have int of a, which will call the get value. Then we have a int of b, which will call get value. And then we'll have a int of c, which will get value. Therefore, now that we have three initializers or three variables, we can then use print calculation and call a, b, c. So then that program should run. So if we then run it, we'll go enter an integer 1, enter an integer 2, enter an integer 3. So what we'll be doing is we're doing 2 times 3, which is 6, plus 1, so we should get the value of 7. Cool, and we do. Yeah. Nice. So in this version, A will always have a value of 1, B 2, and C 3. Operand functions, arguments, and, and sub-expressions may be evaluated in any order. It is a common mistake to believe that the operator precedent and associativity affects the order precedence of evaluation. Precedence and associativity is used to determine how operands are grouped with operators and the order of value computation. Interesting to note. Ensure expressions or function calls you write are not dependent on the order. Okay, again, interesting to note. Okay, so where are we? Quiz time. Okay. You know that from everyday maths, for this exercise you are given a set of expressions that have no parentheses using the operator okay. So, sample problem x is 2 plus 3 modulus 4. The binary operator has a higher precedent, so it gets evaluated fourth. Yeah. Yeah, remainder. That's basically what it means. So x 3 plus 4 plus 5, since they're all on the same level and they're all adds, it would be 3 plus 4 plus 5. So for example, it's 3 plus 4, which is 7, plus 5, which is 13. No, 12, sorry, my bad. Okay, so they're not actually worried about that. Binary operator of and has a higher precedent than or. Okay. Unary arithmetic operators. Two. Unary arithmetic operators, and then we'll do that. So there are two unary arithmetic operators, plus and minus. As a reminder, unary operators are operators that take one operand. Okay, so operator plus is the form of plus x and a value of x. Unary minus is negative. Makes sense. The unary minus operator returns the operand multiplied by 1. In other words, if x is 5, minus x is minus 5. Makes sense. Unary plus is the other way around. For readability, both of those operands should be placed immediately before the x. Yeah, makes sense. Do not confuse unary minus with binary subtraction operator, which uses the same symbol. For example, 5 minus minus 3. Okay. Binary arithmetic operators. That was fairly straightforward, so I didn't actually make a note of that. So let's see, maybe we'll make a note of binary. There are 5 binary arithmetic operators. Binary operators are operators that take a left and right operand. Okay, so I didn't know that there were 5. Oh yeah, the 5th one would be the remainder. Okay, so there are 5 binary arithmetic operators, and then they are these ones here. The remainder of x divided by y. Okay. The addition, subtraction, division, and remainder needs some additional explanation. We'll discuss that later. Integer and floating point division. It's easiest to think about division operator by having 2 modes. Okay. By having 2 modes. If either or both of the operands are floating points, I think I might need to make a note of this one. Integer and floating point division. Integer and floating point division. Okay. When dealing with division, it is easiest to think about it having 2 modes. If either or both of the operands are floating points, so the first mode would be if either or both of the operands are floating point values, i.e. opposite the respective operator, the division performs floating point division, and therefore returns a floating point value. Yeah, for example, 7.0 divided by 4 would be that. Secondly, if both the operands are integers, the division performs integer division instead, and drops any fractions. Yeah, this makes sense. So for example, if you had a signed and unassigned, it becomes unassigned. Using static point to do floating point. What if we have 2 integers and we want to divide them? yeah, you could just use static cast. Yeah. So as always, we can use static cast new type and then expression to convert um, floats to ints or ints to floats or whatever we want. Dividing 0 by 0 produces nan, aka not a number. Yeah, the result would be nan. Okay, that's fine. Arithmetic assignment operators. Yeah, that's fairly straightforward. I'll skip it. I think I'm fine with that. Modifying modifying and non-modifying operators. So modifying operators and non-modifying operators. An operator can that can modify the value. An operator that can modify a value is called a modifying operator. In most circumstances, no. Most operators are non-modifying, and they just use the operands to calculate a value. However, two categories built-in operators do modify their left operand as well as the return value. The assignment operators, i.e. equals, the arithmetic operators, i.e. Plus and then equals, minus then equals, subtract, no, divide, multiply and then equals, divide and equals, or remainder and equals, and the bitwise assignment operators. An increment and decrement, decrement operators. Yeah. So I'll do that. I'll do that. And yeah. Remainder, and I always, when I'm coding, I always struggle with remainder and explanation, especially with the modulus. Sometimes get a bit confused. Remainder and exponentiation. The remainder operator, or known as module operator or modulus operator, is an operator that returns the remainder after doing an integer division. Okay, I think perhaps because the reason why I struggle with it is probably because I've never actually learnt the definition as to what it does. So the remainder operator, which is this, also known as modulo operator or modulus operator, is an operator that returns the remainder after doing integer division. So for example, 7 divided by 4 equals 1 remainder 3, as we did in the previous 7 remainder 3, aka 7.5, aka a third, and that's where you get the 3 from. Therefore 7 modulus therefore 7 modulus 4 will equal 3. Yeah. As another example, 25 divided by 7 equals 3 remainder 4. So 25 divided by 7 equals 3 remainder 4. And that is because right, 3 times 7 is 21, and then remainder 4. Okay, that makes a lot more sense. You take the denominator and multiply it by the result, and then that result is then subtracted by the numerator, i.e. 7 times 3 equals 21, then 25 minus 21 equals 4, therefore giving you the remainder of 4. Okay. Let's again obviously practice that, just so it gets more and more inside of my head. Okay, so we're gonna include input-output stream, return type of integer for our main function, and we'll do standard character output, enter an integer. Then we'll have the user enter the integer. Then we'll set the integer, sorry. Int x. Then we'll have another one for enter another. we do int y, and then standard character input of x. Then we'll do standard character output, aka printing the result. So we're doing get value, and then we're doing print result. Print result. Then the remainder is x modulo y, and then if x modulo y is equal to 0, then we will do standard character output x is evenly divisible by, and then y, and then we'll do a line break, else, and then standard character output x is not evenly divisible by y, and then a line break, and then we will come out of the logic and return 0. So let's do that. Enter an integer 13, enter another integer 5. The remainder is 5 because 13 divided by 5 5 is not, why is that not my y is not an integer. Oh, it's the remainder is 5, but shouldn't it be 13? Shouldn't it be 2? 6, 3. So clear this. Enter integer 6. Enter integer 3. 3 is evenly divisible. That's why. Because I have that. Let's try that again. 6 divided by 3. Cool. And then let's do the 13 one again. 13 divided by 5. The remainder is 3. Because you do 6 divided by 4, 6 divided by 4, and then the remaining 6 because you do, hang on, 6 divided by 4 is 1.5, and then 1.5 then 1.5 times 4 the remainder is 2. Okay. Okay. No, sorry, I was just being stupid. So, sorry. 5 goes into 13 2 times, and the remainder of 3. Yeah, I was just being idiotic. So 13 divided by 5 equals 13 divided by 5 equals remainder of 3, because 5 goes into 13 2 times, aka 5 times 2, equals 10. Then 13 minus 10 equals 3, hence y the remainder is 3. Okay, that makes a lot more sense. Remainder with negative numbers, the remainder. Okay. So operator against 0 if possible. Now exponent. The exponent is that. Where you'll note that the commonly used to the power of, basically. So to make use of the exponent we use the C math header and then use the POW function. We use the POW function. So for example, we'll do include C math and then double X standard standard POW and then 3.0 and 4.0, something like that. Note that the parameters in the return value are a double type. Okay. If you want to do integer explanation, you're better off creating a function by yourself. Assert. So let's do that then. So we'll do include, as always, input, output, stream. Then we'll do include C assert. And then we'll also do include C standard int. Assert for T. And then I know it's not easy, but for input and output. Output. Okay. No, XB must be non-negative. So here we've got a constant expression with a constant expression with a integer of with a return type of integer 64t with the name of POW int. And you have standard int 64t, and then you got the base, aka the operator, and then you got int xp. Oh, int 60, standard of base, yeah, exponent. Then we're going to use assert, which means we need the exponent. And if the exponent is greater than or equal to 0, and power int x param has a negative value. I haven't really covered assert. So handle case 0. So if base, which is standard integer 64, base, if base is equal to 0, return exponent while exponent is greater than 0, if exponent and 1 I think this is just going to be something to continue to use because I don't really understand this. So what does the following expression evaluate to, aka equal to? So so remembering BODMAS. So you got brackets. No, I don't want to save that. I want to save this one. So you got where are we? So yeah, you got BODMAS. So you got order brackets. So it should actually be divide there. So it would be 4 divided by 3. 4 remainder 3. And then 5 times whatever that is, and plus 6. Yeah. So we got 5 times 4, which is 20. And then 20 modulus 3. Which 3 goes into 20 6 times because 3 times 6 is 18. So that's where you get 20 divide. So 3 goes into 20 6 times. 20 modulus 3. Oh, sorry. No, 20 modulus 3. Oh, because you're not. Okay, my bad. So it's 20 divided by. Oh, the remainder. The remainder. Again, see, I'm stuck with this remainder because it's 20 goes into 3. 20. 3 goes into 20 6 times, and 3 times 6 is 18, and then 20 minus 20 minus 20 minus 18 is 2. Yeah, that makes sense. And tell us whether the number is odd or even. Write a constant expression function called isEven that returns true if is passed and false otherwise. Use remainder operator to test whether the integer parameter is even. Make sure is even works both on positive and negative. So we want to, let's give this a go, because this will be challenging, I reckon, for me. So we'll include input output stream, as always. We will then include math. We'll need as always, a main function. We will then have a get value, and we will have a is even, and then we'll have a print result. No. The is even will be void, I think. Void is even. So we'll have a int of, no, it'd be Boolean because we want to test whether it's true or not. Boolean is even. So int get value. So we'll need ask the user to input an integer. So standard character output, enter an integer, and then we'll do int x, and then we'll do standard, that's why, standard character input, and then x, and then we return x. So is even. So Boolean is even. So we need a parameter of int x, and then if x modulus 2 is equal to, is my stream kaput? Wi-Fi is still on. I think my Mac is just, I think we are. I think we're back to it. Just double checking, just want to make sure. My recording system's all good. I just need to wait for YouTube to catch up. So we'll just wait for that to happen. Should be a few seconds. Yes, we're back. Okay, cool. It was just a little bug or glitch. So I think if we did this, return, so if x divided by 2 modulus, modulus 2 equals 0, we want to return standard character output x is an even number, and then we will do this. Else standard character output x is an odd number. Then what we want to do is we can do a, and we call is even, and then within is even we do a get value, and then we do is even a. Return false, and then here return true. Constant expression function. So like that. So if you got rid of that, and make sure it works for both positive and negative. So does that mean we need to use here? We need to use standard int 64t x. Let's have a look, see if that's right. So enter an integer, we'll do 10, and we should get it is even. 10 is an even number. Cool. Does that now work for, say, 11? 11. 11 is an odd number. Nice. What about now minus 10? Minus 10. Minus 10 is an even number. Okay. You may need to use this. Yeah, I did. Okay, let's see if I'm somewhat correct. So we got constant expression of Boolean, yeah, is even. Okay, so we were fine with integer of x for as I had it. And it's oh, hang on. So we moved this into its own function because I want to get used to writing functions in C. And then within here, if is even, if x is even, then x is even. You may have been tempted to write this, which is what I did. While this works, it's more complicated than it needs to be. Let's look about how we can simplify it. First, pull out the if statements. Boolean bool is even is equal to note that if the if statement uh, mm, I mean, surely this will set it to true. I mean, I guess we could do return true. Uh, return true semicolon. See, I just wanted to have it all in one place. And why am I getting an error here? Expected a statement. Is it a delay? So I can't have true there. But the thing is though, if you did if you did if you do it here, uh, the thing is I'm grouping it all together. Now unless I'm just being stupid and inexperienced, which you know is possible, this is setting it to true. And bool is even. I understand that, yeah. If is even. Now note that if the if statement essentially says if is even is true, return true, otherwise if is even is false, return false. If that's the case, we can return is even. Ah. But you still need to do, the thing is, you still need to do the if logic. So I'm just grouping it all together. So now I'm going to write my code more like this. I mean, I could be completely wrong, but that's the way I'm going to do it. Yeah. Okay. Increment, decrement operators and side effects. No, thank you. How are we looking on the stream still? We're still good? Yeah, we're still good. Okay, cool. I'm going to take a quick break here and I'll be back in just a minute. Okay, and we're back. Okay, okay. Right. Me. Okay, then let's continue with operators. Right, let's get back into it. Okay. Close my terminal. Clear that. Cool. Increment, decrement operators and side effects. Often used when doing, for example, for loops. Increment, something to add, and minus the one. Yeah. Apologies for all the ads. Okay. That makes all sense to me. I've done these type of things before. Symbol, form, operation. Okay, note that there are two versions. Prefix, increment, and decrement. So copy X, then so the post is making copy of X, then reducing it, then returning a copy. Whereas this, that makes sense. Post, increment, decrement X. So post, so we're making a copy of X, then increment X, then return the copy. So X is increased to 6, copy the original X is evaluated by the value of 5, and 5 is assigned to Y. So copy the original, then increase it, then return the value. First, a copy is made. Then the original is increased, then so you're basically adding the original and then making the original, you're adding the original to get a new, and then you're making the original equal to the new one whilst also keeping the original. Are tricky. Yeah, they are. First copy, first the copy of the operand is made, then the operand, not the copy, is incremented or decremented. Then the copy, not the original, is evaluated. The x is increased to 6. I understand that. The copy of the original is evaluated to 5. Yes. And 5 is assigned to y. So x becomes 6. So with x and x, for example, with x plus x is increased by 1. The copy of the original x is evaluated, and the the operand, not the copy. Yeah, the operand. The operand, not the copy. So the result and then the result is no, and then the original is increased or decreased. Yes. Then finally the copy. The copy of the original is evaluated and either increased, maybe I think I'm starting to get it, increased or decreased. So include input output stream int x is initiated with 5 and int y is x post increment. So based on that, the copy of the original is made. The copy of the original is made. Yes. Then the original is increased or decreased. Then the final copy is increased or decreased. No, is evaluated, sorry. So basically 5 no 5 is assigned to y, which is why so line 6 into y, first a temporary copy of x is made that starts with the same value of 5. Then the actual x is increased from 5 to 6, yes. Then the copy of x, which still has a value to 5, is assigned to y, yes. Then the temporary copy, i.e. x, is assigned to y, is discarded. Consequently, y ends up with the value of 5 and x ends up with the value 6. So yeah, I think I'm going to need more examples on this. Yeah, I think this is just going to have to be one of those ones where you just keep going and going. So here's an example. So you got int x is 5. Int y is 6. It's 5, sorry. And then x y. And then the prefix I understand. Standard character output, prefix x, prefix y, prefix. So this will produce this will produce 5, 5, and then 6, 4. He says, yeah, 5, 5, 6, 4. Understood. Then x y. So this will produce, if it's written correctly, 5, 5, 6, 4, 6, 4. Right? 5, 5, 6, 4, 6, 4. Then this will produce. Now this is one I have to think about. Postfix. This will produce so we're making a copy of the original 5, or are we making a copy of this 4, which means then we increase it, but we're increasing the original. So x, so then we'll get 5, and then here we're decreasing the original, so we'll get 4. So will it be 5, 4? Or will it be, no, sorry, 5, yeah, 5, 4. Let's have a look. 6, 4. 6, 4. So this is getting the original. No. Postfix. So then we need to print it out again. So that produces 6, 4. So this doesn't actually, okay, I think I'm starting to get it. So this does not actually increase it increase / decrease right away, but rather when we call the variables again, that is where the increase / decrease happens, because x is set to 6 here after all of this. Y is set to 4 after all of this. We're then getting 6 here, and we're getting 4 here. Then, post, i.e. afterwards, post, we are going to be adding. So that means the next time we call x, it will have increased, and the next time we call y, it will decrease. Whereas this is pre, and it just makes sense to me. So that will be 7 and 3. Okay. So when using postfix, it basically means that we take the value that it had, aka at this point x is equal to 6 and y is equal to 4, then we add or subtract. Then the next time we call x or y, that will those values will have increased, or decreased, and that's how we get okay. That makes it a lot easier to understand. Okay, yeah. When to use prefix? In many cases, pre and postfix produce the same behavior. So we have 0 of x. We increase x by 1, and if we were to print out that, we would get 1. Then x were to be this, and then when we call it, it will be 2. I prefer pre. I agree with this, but at least I now understand, or feel I understand, post is to favor prefix over post. Use postfix. Side effects. Okay, we'll see where we are. So it's nearly 20 to 1. We'll see where we are by the time we finish this section here. So let me just do that. Okay, side effects. So a function or expression is said to have a side effect if it has some observable effect beyond a return value. Common examples side effects include changing the value of objects, doing input-output, updating graphical user interface, such as a button. With common examples being that most of the time side effects are useful. Yeah. Side effects can cause audit of evaluation issues. In some, so we have a function that adds and returns. Then we have a int of x of 5, and we have a int value of calling the add function, and then we have x, and then x plus plus x. So it would be 5 and then 6. Oh, but it's undefined. Okay. In many cases, unspecified behavior. When x is initialized to 1. So it entirely depends on your compiler and your IDE. C++ does not define the evaluation, define the order, of function arguments or the operands operator. Do not use a variable that has a side effect applied to it more than once in a given statement. If you do so, the result may be undefined. One exception is, which is equivalent to x plus y, yes. So I want to make a note of that. Okay. So that's that. The comma operator. How many have we got on operators? Okay, so we're about halfway through. And then after that, we got scope and linkage. So comma operator. The time is 22, so I'm just going to take a little break, and then I'll be back probably for about 20 minutes, and then I think we'll end it there. Yeah, cool. Okay, and we're back. Let's hello. Okay, and we're back. Okay, cool. We're back and should be all good on the stream. Let me just check. Yeah, we are. Cool, nice. So let's continue with that. Okay. So the comma operator. Okay. The comma operator allows you to evaluate multiple expressions, whether a single expression is allowed. Wherever a single expression is allowed. So, comma operator evaluates the left operand, then the right, and returns a result. Operator, symbol, form, cool. For example, and we'll just make our own example. Did I copy and paste that? Yes, I did. Cool. So include input output stream, as always, return type of integer for our main function, and then we'll do int x 1, int y 2, and then we will do a standard character output of prefix x, prefix increment y, and then we will do, we don't want curly brackets, we want normal brackets, and then we'll do a line break, and then we'll return 0. Cool. And then so that should return evaluates x, then returns y. Evaluate x, then y, returns value of y. So that produces a value of 3. . So it returns the value of. So does that mean then that if I were to do standard character output X, I would then get 2? Yes, I would. Okay. So this means that only y will be shown, but x will still be increased. Hence, y, if we output x, it will be 2. First, the left operand is evaluated, which increases it from 1 to 2. Next, the right and is operated, which increases from 2 to 3. The comma operator returns the result of the right 3 in our console. Note the comma has the lowest precedence of all operators, even lower than assignment. Because of this, the following 2 lines of code are no different. So Z, Amy. Evaluate, first get the result of B, then assign it to Z. Evaluate says Z equals B. Okay. Most programmers do not use comma operator at all within a single expression, with the single exception of loops, which are fairly common. We'll discuss loops in a future episode. Okay. Oh, that's it. Okay. It is best practice to only use comma loops. Okay, conditional operator. So how long? Time is 10 to. How long is the conditional operator? Conditional operator is quite long. So what we'll do is we'll see how we are by the time it gets to 1 o'clock. So conditional operator. I just want to do okay. So yeah, I thought so. In for loops, typically you only use semicolons, but we can use it to evaluate certain things. Or so in this thing, I assume next position is the only thing that will be returned. but you're still evaluating I and position. Okay, that makes a lot more sense. And then here you're increasing I by 1, but the only thing that will return is position. Yeah, okay, cool. Because in for loops you have the increment, no, sorry, you have the initializer, you have the condition or the range, and then you have the increment. So conditional operator. The conditional operator, i.e. this. Oh, it's okay, yeah. So the conditional operator, conditional, or often referred to in other languages as ternary, i.e. You set what you want, and if it's true, run this, and then if it's false, run this. So the conditional operator is something like this. And is essentially an if statement. A common acronym is WTF, aka what, aka what condition, and then what condition to run if true, else run if false. Yeah, so WTF. Yeah, often referred to as ternary. Shorthand, yeah. If statement is this, yeah, cool. Yeah. So condition, expression 1, expression 2. If the condition evaluates to true, expression 1 is evaluated, otherwise 2. Consider the following example. If can be written, so if x is greater than y, return max equals x, else max equals y. That can be written as max equals if x if x is greater than y, then we print x, else we print y. Yes, although I don't think we necessarily need that in this situation. Yeah, that makes a lot more sense. So if x is greater than y, we print x, else we print y. So again, here, for example, we get a value, ask the user for the value. We have an integer value here. We have a standard character input here, and we return x. Our integer of x is getting the value. Our integer of y is getting the value. And then we have integer of max. If x is greater than y, return x, else y. And then we have a character input. But I think surely we can just get rid of this and we can just put this in here, i.e. If x is greater than y, then we would do the max of x and the max of y. Yeah, surely not. Surely. Okay. I guess we'll go over that later. So I think this is a good place to stop. The conditional operator evaluates as partner expression. So just copy and paste that, and then we'll make a note of left off at less than 6.6, and then cool. So what did we do today? Today we did on day 11, part 2. We did starting on operators. How they can be used to evaluate an expression. The table of precedence. And associativity. Binary arithmetic operators. Integer and floating point division, and how it affects results. We can use static cast new type expression to do what? To adjust this. Remainder and exponents. Modulo slash modulus explanation, exponentiation with what was it? Include math, CMath, and using the POW method. And remember that a method is just a function within an object. Explanation, we did the quiz, we did increment, and decrement. We did pre and post increment and decrement. Side effects. And then we finished off with the comma operator, which prints / produces the output of the expression to the right, but still evaluates the previous operands to the left. Yeah, cool. Tutto bene. And the date today is the 9th. 6. Okay, cool. Let me clear the terminal. Let me commit. Let me make it better to look at. Let me close that. And yeah, hopefully today you enjoyed learning about the operators. We've still got a fair way to go on operators. So what have we got? We got the conditional operator, which is what we're doing now. Relational operators and floating point. And then we got logical operators. We've done some bit set, so I'm going to skip over that for now because it's an optional. But after that, we're getting onto the fun stuff like local variables and linkage. So hopefully it shouldn't be too difficult because we've done some local variables, i.e. when they're destroyed after the body, things like that. And then after that, we've got some more constant expressions, some if statements, and then we got the nice, more interesting for loops. So let me just open that again. So it's left off. So when I open the page, it'll come back. So if you've been enjoying, please like. If you've noticed something that I've done that I shouldn't have done, or noticed something that you liked and wanted to talk about, let me know in the comments. But yeah, if you could like, subscribe, and all that good stuff. And I'll see you in the next one. Hopefully you're enjoying C++. If you are, let me know. But as always, yeah, please like, subscribe, and peace. And I'll see you in the next one. All right, bye.